Okay, so today we're going to talk about the tangent function. The tangent function is a little bit different than the sine and cosine functions. And remember that we got our function values from our unit circle when we were developing our graphs for sine and cosine. Well, we're still going to get them from our unit circle, but our tangent graph looks very, very different. So let's go over a few things. The tangent function has infinitely many points of discontinuity, a word you haven't seen since we did rational functions, with a vertical asymptote, infinitely many vertical asymptotes in total, at each point. Its range is all real numbers, which is very different from sine and cosine. And its period is pi, half that of both the sine and cosine functions. Its domain is all real numbers except odd multiples of pi over 2. Okay, so here's where this comes from. Suppose the terminal side of an angle theta in standard position intersects the unit circle at the point xy right here. Then the ratio y over x is the tangent of theta. So keep this in mind. X equaled cosine theta, y equals sine theta, and y divided by x is what gives us tangent theta. So that's where our tangent value comes from. We're going to take our y value and divide it by our x value. So we're going to do some of these at the bottom of the page. I've got the tangent of pi. So go to your unit circle and go to pi. And you'll see that at pi, the point on the unit circle is the point -1, 0, right? All right. So I'm going to write this here, -1, 0. This is my x value, and this is my y value. All right, so my tangent value at pi is my y value over my x value, which is 0 over -1 equals 0. All right, let's do another one. We're going to do tangent of -5 pi over 6. So let's go to our unit circle. And here's 5 pi over 6. Would you agree that -5 pi over 6 would be going the same amount in the clockwise direction, which would land us right here? Agree? So my coordinates are -√3 over 2 and -1 over 2. So I'm going to write that down here. -√3 over 2 and -1 over 2. And keep in mind, this is my x value, this is my y value. So my tangent value is y over x, which is -1/2 divided by -√3 over 2. Now you're looking at that going, oh, I don't know what to do with that. Keep yours flip. So -1/2 times -2 over the square root of 3. All right? Keep, switch, flip. The 2's cancel, the negatives cancel, and I get 1 over the square root of 3. Rationalize your denominator by multiplying by the square root of 3 over the square root of 3, and we get the square root of 3 over 3.
Wait, from in the beginning, how did you find that again? Because I know you go -5 pi.
5 pi over 6 is here.
Yeah.
Go this amount in the negative direction, and you get to here.
Oh.
That's my point.
Okay. Thanks.
Okay, so let's graph our function graph. And we've got a lovely graph of it right here. And that's, believe it or not, if we go to our unit circle and we find some values, we can actually graph this. So one of the first things I do is go to 0 at 0 radians, y over x is 0 over 1, which is 0. All right? If I go up here to pi over 2, would you agree I have 1 over 0, which is what? Undefined. Right? Okay. Well, at pi over 2, that is going to give me a vertical asymptote. And if I go backwards to negative pi over 2, I've got negative 1 over 0, which is undefined. So at negative pi over 2, I've got a vertical asymptote. All right? Here's one I love. Go to 45 degrees, pi over 4. And here's why I love this. Because x and y are the same, right? So y over x is the same as anything divided by itself is 1. So if you go over here to the graph, I have right here pi over 4, 1. And if I go negative 45 degrees right here, I have negative 1. And that's right here. So here's where this graph goes. It's going to go infinitely up this way, and it's going to go infinitely down this way. And after the next asymptote, this pattern is going to repeat all over again. All right? So this is a periodic pattern because it does repeat over and over and over again. But you see how we've got a lot of asymptotes here. So some characteristics is, suppose we have y equals a times tangent b theta. You remember before a was our amplitude? Can you see how this does not have amplitude because it goes infinitely upward and infinitely downward? A is still a measure of vertical stretch or compression, but it is not amplitude because the tangent function does not have amplitude. All right? Pi over b is the period of the function. So when we're trying to find the b value or trying to find the period of a tangent function, know that pi over b is the period of the function. One cycle occurs in the interval from negative pi over 2b to positive pi over 2b. And there are vertical asymptotes at the end of each cycle. Okay? So, here's what we're going to do down below. I've got one for us to graph, and this is y equals tangent of pi theta. So here's what that pi is. We're saying b equals pi because we have a tangent b theta. So our period is going to be pi over b, which in our case is pi over pi, which is 1. All right, so here's what we've got. Right here, going up this way, down this way. That's just it. I guess you say it repeats itself again. So this guy goes up this way, this guy goes down this way. You can keep repeating them to the left as well. Do we have another page? We do not.